Hello, ladies and gentlemen. I am Mr. Tsebe, and today we'll be doing GERSH-GORIN cycle theorem. But what is a GERSH-GORIN cycle theorem? GERSH-GORIN cycle theorem is a method of approximating eigenvalues. So we can say let di be a disk and then this sign be a complex plane. So this is the theorem that we are having right here. We are saying that all this disk is equals to the integers which belongs in the complex plane in the absolute values of that integer, and then this aii will be the numbers that will be subtracting diagonally, and this will be less than or equals to the summation where it is equals to 1 in the absolute value of all the radiuses. This will be the radius, will be the sum of the radiuses. So this part is the part of the radiuses, and this part is the part we will be separating diagonally. And this eigenvalue, it belongs to the union of these disks, from disk 1, disk 2, all the way to disk n, depending on how union they are. So let's take an example. Suppose we're having a matrix A which is equals to 4 1 1 0 2 1 minus 2 0 9. But our theorem states that di equals to all the integers which belongs in the complex plane is z minus aii less than or equals to the summation of all the radiuses, the absolute value of the radiuses. So this is how we are going to do this. We are going to check this number and this one and this one is going to work like this. So we are going to say d1 equals to z, which belongs in this complex plane. Z, in this case, what is the first number? The first number is minus 4, less than or equals to. I set the summation. So it means that we are going to add these two numbers, 1 plus 1. So it will give me 2. And 2 will be my radius in this case. So let's check for D2. Z, which is equals to a complex plane of. So Z in this case will be minus 2. Less than or equals to 0 plus 1, which is just 1. So my radius in this case is 1. Let's check for D3. D3 is actually ZE, which belongs in this complex plane. ZE, which belongs in this complex plane of Z. In this case, it's Z minus 9. Z minus 9, which is less than 0 plus 2, which is just 2. So we don't take the signs into consideration when doing this. Why? Because of here we are having an absolute value, and it will just be positive. So we don't take the signs into consideration. We just add. So right now we have formulated our GERSH-GORIN disks. It's time we draw our GERSH-GORIN cycle so that we can see where our eigenvalues lies. So we're having this line, and then we are also having this line. So this is the imaginary line, and this is the real line. So let me choose a scale. Let me say 2, and this one will be 4, and this one will be 6, 8, and let me just say 10. And here is going to be 1. Let me take this one somewhere here. So that is the scale that we are having. So here it means it's going to be 1, and then somewhere here is going to be 3, somewhere here is going to be 4, 5, 6, 5 here, 6, 7, 9, 9, 7, 5, and 3. So we're going to be having something like this. So let's check this one first. So this one we're having 4. So this 4, it actually lies here. So but let me draw this scale also. 1, 2, 3. Minus 1, minus 2, minus 3. That is the scale that we're having. So we're having 4 here. So this 4 it has a radius of 2. So it will go to 5 and 6. Because of 4 plus 2 is 6. So it will be somewhere here on 6. So if I take this 4 and I go this side, it will 4 minus 2 is just 2. So it will be somewhere here. But my radius is 2 going up and then 2 going down. So that's what I'm having there. So this is gonna go like this. When I'm drawing this cycle, it's gonna go like this. So let's check the second one. The second one, the main thing is 2, and 2 is here. 2 is here. So what is my radius? My radius is 1. That means it will go from 2 to 3, and then from 2 to 1. Because of here is 1. And then going up, my radius is 1, and going down, my radius is also 1. So this will go like this. This will go like this. So if you can check this out, guys. Here we are having what? 9. So 9 will be somewhere here. But my radius is 2. That means from 9 plus 2 is 11. That means 11 is somewhere here. And 9 minus 2 is 7. So this means this will be here. And then this will be here. And then my radius is 2. So it will be 2 going up, 2 going down. So this and this one, they share the same radius. So this will be the same as, it will go here, and then it will go here again, then it will go this side, and then it will go that side. So these are my Gregorian circles. So guys, please forgive my drawing. So you can see that lambda or eigenvalue lies between this one and in union with disk 2. It falls within this range. It means that all the eigenvalues, we are going to get them on this range. But it's also possible that we get one eigenvalue here or none. So all the eigenvalues will fall within this range. Or you can go further by saying it belongs in this. What is D1? D1 is Z, which belongs in complex plane Z minus AII, which is less than the summation of I equals to 1 AII in union with this one. You can write it somewhere here. So ladies and gentlemen, this brings me to the end of our session.